Hi, TE Academy students. My name is Angela Greitenweiss. I'm founder of TE Academy. And today I'd like to welcome Shermin Voshmgir and Michael Zargham. Thanks for joining this session. And we'll discuss today your paper, Foundations of Cryptoeconomic Systems, which you first published in 2019. Now, almost 3 years later, this paper is still a guiding star for this discipline, trailblazing this new field and token engineering. And my first question, you have a background in information systems, Shermin, and systems engineering, Z, Michael Zargham, and not in what one might expect in economics or finance. So what brought you to cryptoeconomics? Maybe Shermin, if you'd like to start.
Well, that's not entirely true. I studied business management, and with the focus on information systems. So I had a lot of business finance and economics classes, and so I do have some background, but I'm not a full-fledged economist. That's true, and I've never focused on finance. In fact, I had to laugh because I never had great affinity to finance, and then I found myself in a very highly financial field 20 years later. So that's quite funny for me.
And what got you fascinated with cryptoeconomics then?
Well, when I first stumbled over, I think it was at a party in Berlin, very late at night, when a friend of a friend told me what he's into, and he said something blockchain, and I'm like, what's blockchain? And he said something technology Bitcoin. That was, I think, 2014. I'm like, technology Bitcoin, But then, it's a party, and then, it's not very coherent. Next day I wake up, I'm like, what did he talk about? And then I was like, what was that thing? So how do you remember the term blockchain, right? And then I'm like, okay, technology Bitcoin. I started researching, and I can't tell you, it was just this major gut feeling I had. I was stuck to the internet for 12 hours and trying to figure out what this blockchain thing is. And I had this instant gut feeling that it's more than just a technology, that it's kind of an operating system for resolving a lot of but I couldn't say it in the words I'm using today, right? But my gut feeling was it can resolve a lot of the economic and social challenges we have. But I didn't, that was a gut feeling. And based on that gut feeling, I just started a website. Back then it was a Tumblr. And as I started learning what blockchain is, I started sharing it on my Tumblr, and that eventually became the Blockchain Hub, which was then kind of a think tank learning institution in Berlin. And then later on, went on to Vienna, where we created the Research Institute for Cryptoeconomics. Back then, there were some people in Vienna at the university and in politics in Austria who said, oh, blockchain is the new thing. Why don't you come here and create this research institute? We'll give you initial funding. And then they wanted to call it blockchain. And I said, yeah, but it's not really about blockchain. Blockchain is just a building block. It's the cryptoeconomics that is really behind blockchain networks that is the game changer. And this is why we call the Research Institute Cryptoeconomics. And eventually, I met Michael Z, and we who started to collaborate with us at the Research Institute, and we started to write this paper. So that was kind of my story. It was all quite random.
Great. And Z, is this sounds similar or feels familiar to you, or how was your journey from complex systems engineering to cryptoeconomics?
Yeah, I think my journey started with sort of a wide range of studies on technical and social systems interplay. So I did some sort of civil and environmental engineering as an undergraduate and moved into robotics, worked on large scale multi-agent systems and algorithms for coordinating the activities of multiple robots or other sorts of mechanism design problems that assumed some sort of human agents or otherwise actors outside of the immediate control of the designer, but with some overall purpose or objective that you wanted that system to achieve. And I worked in a variety of fields, kind of on the robotics side and on the sort of business algorithmic policy making side over the course of several years. And when I first got kind of introduced to blockchain, sort of what we now call Web3, I had a similar enthusiasm to Shermin, which was not so much about the particular technical building block, but about the sort of the things that it unlocked to be able to have a sort of public, permissionless, shared state of the world that you could use and even program for policy making purposes, and sort of got excited about what people might do with that. I did some work on Web3 startup, a blockchain startup in 2015, and then sort of like got a little bit burned out on it. And I was like, oh man, maybe this is all a scam. And then I was like, took another, like after a year of working on Web3 stuff, 2015 into 2016, and then kind of like a hard break, 2016 into 2017, and then came back into it again, 2017, with a lot of enthusiasm again, after sort of having some time for things to play out a bit, and kind of jumped in whole hog. And in, I guess it was 2018, where I feel like it was at TEGG that Shermin and I met. And we, which Angela, you were an organizer of, and then started collaborating. And then
it was 2019. It was 2019. Yeah.
TEG was 2019. Yeah, we we got together and started sort of merging our different experiences with different backgrounds and trying to look at the way these complex socio-technical systems sort of emerged from the synthesis of the technological affordances and the sort of human behavior within and around those affordances.
And you
know what it was actually, Michael? Actually, I remember we met in Vienna earlier that year in 2019. You came for a conference we were organizing there on SDGs, blockchain and SDGs. But it was really when I shared with you a chapter of my book I was writing. It was the first edition of Token Economy. And I asked you for feedback on the chapter Purpose-Driven Tokens. And I remember it was like in the morning in Europe. So it must have been like after midnight where you were. And then like an hour later, I get a 2-page email with thoughts on it. And then you're like, I already commented that the chapter was full of comments. And I'm like, whoa, that guy, like, because I was like even scared to ask you for feedback, and you you gave me so much dense feedback within a short period of time. And I think this is when we natively understood that we have the same perspective on this thing, but we were speaking very different languages prior to that, because we have very different backgrounds and we didn't have a common language to exchange. But based on this purpose-driven network, the purpose-driven tokens chapter, I think this is when we got together and started to exchange more ideas. And out of this purpose-driven tokens chapter is, I think, what then also spurred the idea of writing that paper from that perspective.
Yeah,
if you remember.
That's fair. And I think the thing that's important to understand is that one of the main thrusts of the paper was to try to do some language unification. So, for better or worse, it's a bit survey-y. There's a lot covered, and we don't go as deep in anything as you might like, and personally as I might like. But over the course of the paper, we actually really try to say, all right, let's pick a perspective, and then let's look at what we can bring from that perspective, and let's look at the language that comes from that perspective. And then we sort of find ourselves going to the next one and then saying, okay, what can we draw from this perspective? What's the language that we use in that perspective? What insights can we draw from that? And sort of by stepping through at that level, we sort of lay the groundwork for actually allowing people with different backgrounds to have coherent conversations about this topic.
Right. And let's go over these perspectives, because I think it's pretty interesting that you took this. Okay, let's map out the variety of perspectives one might take on cryptoeconomics. And the first one is complex systems. I think, Michael, that's your background. Why is it relevant for cryptoeconomics?
Sure. Well, so complex systems is a pretty broad concept, but it basically amounts to something being greater than the sum of its parts. And so for better or worse, we're basically saying that you can't reduce it to an arbitrarily simple description. And this is one of the reasons it's sometimes hard for people to grok initially. You've got maybe simple parts, but interacting in complex ways and giving maybe not totally expected consequences or outcomes. And so, at least for me, I felt like it was really important to get past the point where if it's not simple enough, then you don't understand it. I don't totally dislike the idea that you should be able to explain something simply, but it also depends on what's in scope. So like if you narrow the interest far enough, you can say, okay, I can explain this small bit simply, but as I zoom out and I get this complex interaction between many simple things, it's not totally fair to say that if I can't describe it simply, then you don't understand it, which is a common heuristic. And I think, yeah, I tend to look at complex systems as having that property where it's okay. In fact, it's even right to say that each individual concept, principle, or individual bit should be simply articulated, but that the really interesting stuff comes when combining all that simple stuff does not result in like an obvious or simple outcome.
And could you give an example to make this a little bit more tangible when it comes to token systems?
I wouldn't even go to token systems. It's policy making in general. So like if you look at like a socioeconomic system, what's happening is that a group of people are trying to come to some decisions, you might say some algorithms, that are going to affect themselves and others as those people operate within that system. And so anything that looks like, we collectively aside to assert a policy, a rule, an algorithm, which then we are all exposed to, can be very simple in the I want this, or this is the outcome I want, this is the outcome you want, this is the mechanism we're going to put in place. But then the outcome is never that simple. People have differences of opinion about what means good, what are the goals. Go ahead. Shermin.
I'd like to maybe chime in with some recent example, right? So it's easy to understand maybe asset tokens, right? Tokens that I use as a collateral in a DeFi product. And the DeFi products are kind of these money Legos, and they're easy to understand also. What's decentralized lending, what's decentralized, what does an exchange do? But then the interaction of these different components of these money Legos in themselves, they're very complex. And it's hard to understand for a person from the perspective of like putting some money into Terra Luna, that maybe that might explode a few months later, because most people don't understand the complexities of these money Legos interacting with each other, which is why it's really, and this is a very good recent example for why tokenized systems and blockchain networks, at the core, we have the token, right? And we design different token types that can be more or less complex, but these token types interact with each other with different types of decentralized applications, and they represent assets. And then we have the people who manage the assets and the institutions that manage the assets based on several layers of infrastructure. So this whole thing is a complex socio-economic and technical infrastructure upon which the interactions happen. And the complexities are often only then seen when we have negative black swan events like a few months ago with Terra Luna, for example.
Composability is a double-edged sword. So it's a wonderful opening. It means because of the standardization of things like an ERC20 or a 721 or 1155, these are Ethereum standards, you create this composability and people start building these things on top of each other and causing them to have these interactions. But on one hand, you have the simplicity maybe of the individual logic of the particular mechanism or token system. When you compose them, you get this complex network of interconnected things, and that's not going to behave simply. You might be able to describe it or summarize it simply, and there's nothing really wrong with that, but the underlying network of interactions, like functional compositions, is not something that you can, especially with foresight, say this is exactly how that's going to play out in a simple way. You might tell a story about how it might turn out under some circumstances, but as long as it's open and permissionless in the sense that people can build on it and make their own decisions about how to use it, there's going to be these sort of, again, complex compounding interaction effects, cascade effects that just come with the composability territory. So you don't get to say, I want composability and simplicity. You're like, I either get simplicity or I get like the loss of simplicity that comes with this open-ended composability. And so with Web3, we've chosen that composability, and that brings us to this complex systems paradigm where we're like, okay, well, we chose composability. What does that complexity, buy us? What do we get? What do we lose? How do we deal with it?
And in the paper, this is maybe related also to the multi-scale perspective, right? So what do you mean with multi-scale perspective?
Sure. So the multi-scale perspective is a discussion about micro, meso, and macro lenses. So a micro lens is like an agent looking at their immediate incentives and taking a decision. A mesoscale is about like, and this is generally like the institutional economic scale, is about like the community taking a decision about policy making. Okay, how are we going to go about allocating funding to our community members? How are we going to decide whether we want a monetary base increase that extends the token total supply in order to fund something? It's going to be like any of these policy making sort of like group dynamics where we're like, okay, this is what we're going to do, and here's how we're going to bring it into existence. And then in our view, that the macro scale relates to then what the sort of measurable consequences of that on the system writ large. So in an inflation like dynamic, you're saying we increase the monetary base a certain percent a year, and so maybe the token's market price is declining, or its buying power is being reduced, or there's some other like measurable at the like widest scale where you're collecting data and looking at the outcome and saying, okay, well, when we zoom all the way out, we see this simple number or this simple set of metrics. We want those metrics to go in a certain direction. Okay, back to meso, we're going to make some policy with the intent of having that outcome. The policy in turn influences the individual decisions that people take, which is back to micro, but then those individual decisions actually end up perturbing or impacting or even creating the very metrics, right, that we look back at the macro level. And so really that perspective is about understanding that even though those things are very different in their scope, they actually end up being entangled with each other. The individual decision-making model versus the community sort of policy-making model versus the like system-wide outcomes of both those individual decisions and those sort of group-level policy decisions.
Right, and you highlighted in the paper also the relevance of the institutional economics perspective, and you already mentioned it. You want to elaborate on that one as well?
Yeah, I think I'd like to I think what I found striking from the beginning when I got into the space was this narrative that we're getting rid of institutions. This like getting rid of the middleman and everything is executed by code and we don't have any institutions anymore. And which didn't make any sense to me, because actually these blockchain networks in themselves are a new type of institution. And they're and there is this whole institutional economics, or from an economic side, it's institutional economics. From political side, it's foreign relations, or no, not foreign relations. It's political economics that describes the different types of institutions, and these blockchain networks are a new type of institutions. They have human agents, the developers, the miners, etc., and of course the users. They have computerized institutions. Like the code is kind of the computational constitution of these new types of institutions, and that enforces a lot of the policy making, but some of the policy making is formalized in this computational constitutions. But then again, we have some non-institutionalized or informal policy making of how certain network actors act, for example, in doing upgrade proposals for the code. So describing this new type of institution and understanding blockchain networks and other Web3 networks as a new type of institution is very important to counteract this narrative that everything is resolved by code. And even if it were, right, this code is a new type of institution, but who decides what goes into the code? This is the new type of politics, right? So while the original founders of Bitcoin might have wanted to get rid of institution and politics, they just created a new type of institution. And I root for this new type of institution. There is a lot of potential with this new type of institution, but it is an institution nonetheless with a lot of politics, and we can see it with every major protocol upgrade we have in the Bitcoin ecosystem, in the Ethereum ecosystem, or in any other of these blockchain ecosystems, or in the DAOs. It's always people who have different interests, who want to go into different directions, and there are power structure in these institutions. And to be able to talk about this is very, very important. And trying to ignore the fact that, for example, talking about the upcoming Ethereum proof of stake transition and the power structures that we currently have in Ethereum around who holds the tokens and the potential of, for example, exchanges being able to stake those tokens. These are power structures. They're institutional power structures, and pretending that they don't exist doesn't really solve a problem. It creates a whole lot of other problems that you don't anticipate if you try to ignore these facts.
Yeah. And so I would like to take that as an opportunity to explain why token engineering is important to me. And that is that historically the engineering discipline is an institution, and that institution is a social institution that provides a sort of check on, or like a guidance for, the application of technology in the direction of benefit for some constituency, for the public, however you want to construe that. And so the difference between sort of acting as an engineer and maybe just a designer or a developer is that an engineer has a degree of sort of fundamental obligation to sort of accept and work within what Shermin just said, which is to say there are politics, there are power dynamics, there is a set of stakeholders. You understand that the playing field is not even, that it is not an apolitical thing where you're like, oh, technology has no impact, it's just how people use it. Like, that kind of phrasing is one where you say, well, I'm going to do what I'm going to do, and then whatever. An engineer asks questions like, who are the stakeholders? What is the field of action look like? What are the power balances or imbalances that I want within this system? And actually proceeds to try to, do a service to the constituents of that system. And so, at least for me, this ties really closely to Sherman's point about institutions and the sort of native politics associated with making policies that are entrenched in algorithmic institutions, and asking not just whether the code runs, but whether the code serves its purpose. Does it actually help the community achieve its goals? Is it being, again, I'll air quote fair, because fair is not a thing with an objective definition, but at least a contextualized definition where a community of stakeholders has at least accepted that the particular process or outcome is legitimate, and that they are essentially binding their choice to participate or their choice to make policy within a cryptoeconomic system to some kind of outcome, both at the micro level, which is how they feel about the decisions that they're taking and the consequences of those decisions, and at the macro level, which is how all the decisions of all of the participants roll up to some sort of metrics that help us understand, oh, are we actually doing something new, interesting, fair, ... etc., with regards to the metrics that we might define, compute, and track against at the macro level.
Yeah, you touched on the decision-making and crypto economic systems as new institutions. I wonder, What role does the token play? So I found your definition of tokens in the paper particularly interesting because you don't look at tokens as new forms of money or claims or rights. Instead, you say tokens are atomic units of system state. Shermin, why do you define it like that?
Well, because the state of the system, I mean, tokens do represent a set of rights also, but I think we were more on an abstract academic level, explaining it as the atomic unit, because in the end, at least from my perspective, this collectively managed ledger manages the state of all tokens, right? And the tokens are these atomic units of economic values and rights and interactions that flow, and we can now measure these token flows and the interaction patterns between the different agents in a network in these new economic networks, which also means that we have a completely new type of real-time data-driven economic system where we can use new concepts and of applying economic modeling on top of them, right? Because our current economic systems don't work with real-time data, even in the internet-based world. Our current economic systems are still predominantly work with steering mechanisms, economic steering mechanisms, whether it's on a micro or on a macro level, where economists come in after the fact, once every few years. It used to be every 10 years, make census, have census data about, or once a year, they have some statistics, and based on the statistics, they do the kind of economic steering kind of after the fact. And now we have these new internet-based, Web3-based economic institutions, and the tokens represent the atomic units of value exchange. And based on that value exchange, we can do completely new types of economic modeling using, for example, AI-based AI models, right? So I think the intersection, and this is where the interdisciplinary approach becomes very important. We can use computer-based tools, and here Michael can tell us much more about the advances we've made in data science to evaluate these real-time economic systems and have more steering on the fly, and maybe have new types of economic steering between computers and humans, right? Because our current, just to close this, our current blockchain networks are kind of still the dinosaurs of blockchain networks. It's like humans doing policy making kind of in code and defining it, right? But like, what if we could use the power of AI at some future date to do some of the micro fine-tuning of this policymaking? Z, maybe you can chime in.
Yeah, I was going to say, depending on how you define or bulk the concept of AI, like the domain and domain that I have particular expertise in is called control theory, and it relates to feedback rules, where you have the current state of the world as a either observable or estimatable thing as an input to a process that makes a change to a decision-making rule, and that creates a closed feedback loop with the system that is being controlled or regulated or essentially steered. Then you might say that we're sort of already kind of like dabbling in that territory, but there's only the sort of most basic concepts of feedback control or sort of feedback-based policy making in Web3 at present. So Bitcoin's difficulty controller is quite fundamentally a feedback control law. You start to see other feedback control laws in any system that says the way that it provides rewards or steers resources is fundamentally dependent on the current state of the system, not just a rule that was prescribed in advance and plays out in a quote open loop way. So the Bitcoin mining rewards is open loop. It says as time goes on, block height goes up, and then as block height goes up, the mining reward declines. That's not a state feedback rule. It's an open loop rule. It just says as time moves forward, this policy changes, but difficulty controller is a closed loop feedback control rule that says as hash rate goes up, the difficulty of the problem that you're solving goes up, and actually vice versa. So just like that's a very hopefully concrete enough example to understand why we start to think in terms of policy making and in terms of feedback rules that make decisions based on state. And once you sort of like take some time to absorb the essence of what state feedback control or state feedback policy making can do or has done in other technical domains, then you can come back to this definition of a token and just actually ask yourself, oh, okay, the state of the system, or the information that constitutes the status, the state of the world, insofar as the world is bounded to one of these systems, is encoded in these tokens. And it doesn't even matter whether they're transferable tokens. It's not about, fungibility, non-fungibility, transferability, non-transferability. We're really just talking about if you took a slice in the moment and said, what is the profile, what configuration is the system in, then the state of the state machine tells us how it's currently organized. And the thing that people get in these systems is affordances that allow them to change it. I send you a token, I mint a new one, I deploy a new smart contract. All of these things, they change the state of the state machine through affordances that are effectively permissionless. Now, I could also deploy a thing that has permissioning. That's totally fine. But like deploying the permissioned thing was done permissionlessly. And so that state is the snapshot of the configuration of this shared community computer or this shared world. And what we really needed was to understand that shared state of the world, that public thing that we could all see, we could make policy against, that we can hold policymakers accountable for against, that we can take both our individual actions and our macro level metrics. It all comes back to what is the current state of the world vis-a-vis where are all the tokens, rights, etc., and what are the affordances through which those values are changed, and like what kind of trajectories or trends have they produced under what circumstances. I don't know, Sherman, if you have anything you want to add before.
Make it more tangible, or to add to what Z just said on an abstract level. It's like, what are we doing here on the farm? So I recently bought a farm in Portugal, where we will do some data-driven agriculture and tokenization based on this data we're collecting. And then we can add some policy making on top of all of this. So so what we're measuring here is also like the interaction patterns. So we're trying to measure like the impact that certain agricultural practices have on environmental factors such as water retention, soil quality, CO2 capture, biodiversity, quality of output of the foods produced here, right? And these output factors interact with each other. And now we want to apply sensor technology to measure what's happening and have blockchain wallets like tag each olive tree with a blockchain wallet and feed the system with soil quality data about what's happening around the olive tree and whether the olive tree is still there. But then the interaction, and now we have all this data, and then we can create tokenized proofs. But what happens on, for example, a proof about CO2 capture or water retention, but what happens on our, for example, farm, also interacts with what's happening somewhere else, right? And maybe the evaluation of a CO2 certificate will depend on how many CO2 certificates are being globally issued. Yeah, so this would be a little bit more, we need to go in depth, we don't have enough time, but this would be more the applied version of what you can do or how this impacts what we tried to say before and what Z tried to explain.
Yeah, cool. tangible example. Thanks. Now, summing this up, in your paper, you suggest 6 future research directions. And again, this was back in 2019. Now, I wonder, 3 years later, Sherman, what's your point of view? What have we learned in the meantime since then?
I think my take from what has happened in the meantime is that what we've propagated, this complex systems perspective and the interdisciplinary perspective, we never really talked about this, right? I think we skipped that one. It's very important, and it's still, in my opinion, it's missing in a lot of the teams that are trying to build really cool solutions to real life problems. Very often the teams are still very technologically driven, and they try from a technological perspective to resolve environmental issues, to resolve social or economic issues, and very often maybe lack the know-how in the domains where they're operating, and ignoring the complexities and also the interdisciplinarity of the kind of solutions they're building. And I can just tell you that one of the projects Michael and I were working on 2-3 years ago was with a blockchain infrastructure kind of team. And after working with us, they wanted to hire 1 economist. Now they already had 200 engineers, and they thought that hiring 1 economist was already like a good idea, not understanding that economics has so many different perspectives. You have microeconomics, macroeconomics, institutional economics. They're trying to hire 1 economist, and they're building this complex socioeconomic system, right? And unfortunately, not much has advanced. The teams are not interdisciplinary enough for the complex things they're trying to tackle and they're trying to build. So unfortunately, I think if Token Engineering Academy can create more awareness around the necessity of more diverse teams, and diversity means also parity, like just having like 1 token economist and 1 kind of political economist or political scientist and 1 social scientist on board of 300 people is not enough from my perspective. See, you've had some much more closer interactions with teams lately also. What was your experience?
I would say, I think it also depends on the level and the role of those people. So I definitely agree with you, parity is an issue, and you can't just be like, oh, we have an economist now, or we have a political scientist now, and ta-da, we can check that box and now everything's going to be great. The thing that I find important is, again, drawn from like a civil engineering perspective, which is to say that like, it's not about building or deploying the tech, it's about what the tech does for those it's meant to support. And you can't address that from inside. And so in a engineering context, you talk about the difference between validation and verification. Verification is like, okay, did I implement the thing that I intended to implement correctly? Validation is like, did I implement the correct thing? The tricky part about this is they're extremely asymmetric. You can pretty much always do verification by looking at the spec and really like beating the crap out of the thing that you built to make sure that it satisfies the spec. But the validation question, which is like, did we drive the desired outcome in this like sort of sense of, did we serve the constituents of the system? Is the current set of policy serving the purpose? Are we following the principles of the organization that is underwritten by this code? You're pretty much always going to end up in fuzzy territory. And, you know, I think in the Web3 space, there's a tendency for people to be like, oh, well, if it's fuzzy, it doesn't matter. If it's not directly measurable or objectifiable, then we just ignore it and we focus on the things that are, because that leaves out things that are never going to have that property. And I think it was Danella Meadows who rather famously said that things like democracy and I mean, she listed off a bunch of terms, but they're actually intangibles, and that you don't code the fact that you have a meaningful say over the institution that affects your lives and say, oh, cool, I checked the democracy box. We have voting now, so therefore it's a fair and inclusive system. Actually, the concept is an intangible that is derived from the experience of the constituents of that system. Yes, I do feel like I have a meaningful say in this system, and I do consider the outcomes legitimate even when I don't agree with them, because the process that we use to make the decision, or the historical sort of context is there. And I think these are all the kinds of intangibles that the economists and the political scientists, the social scientists are sort of trying to bring into these systems.
I don't think they're intangible. Sorry, I don't think they're intangible. I think they're multidimensional. And what startups don't like is multidimensionality, because that's more complex, and that makes them slow. And in fact, you can see tweets from very prominent, let's say, ecosystem drivers, who then tweet things like, yeah, if you can't put it in a sentence, I don't need science, stuff like that. But they're building complex networks. Like they're managing DAOs that manage a lot of funds, yet they don't have the patience to hear, because sometimes a certain level of complexity is necessary. And democracy is measurable, but it has various dimensions, voting rights being one of them, but not, so I did a whole thing on democracy. So, and I think it's harder to make them tangible. It's more complex to make them tangible, and nobody has the time, because everybody wants to do some more fundraising, and they're have a burn rate, and they want to do this and that, and it's time. And complexity is low.
I want to take that a step further, though, that like when there's high complexity, then you have to choose a lens with which to measure. And so part of the reason that like this becomes kind of a mess is that there's a subjective framing act that says, here's what I care about, here's what I'm measuring, here's my view or my perspective on the complex system. So you could look at something and say, look how democratic it is. We all vote, and the outcome of the vote is automatically the decision. But that's putting the process ahead of the substance. There are other scenarios where you might put the substance ahead of the process. Maybe we have a really small community, and we have discussions and deliberations, and then we just iterate until we have some consensus, and then there's some process of ratifying or bringing the thing into existence that we have debated and eventually arrived at. Neither of those is democracy, where the other one isn't. They're both ways in which the constituents of the system come together to make a decision, and then that decision is affected on the system. And sometimes I think, especially in Web3, where we have a really algorithmic bias, we say, if the procedure satisfies some checkboxes, then it's democratic, rather than looking at the sort of the fundamentals, which are the people who are beholden to policy that you're making party to the decision of making the policy, and in a way that is like meaningful for them.
Yeah. Now this sounds already like, okay, keep this in mind, and like a recommendation for the students to close the session. Now imagine we have numerous students who are excited to become token engineers, reading your paper, Foundations of Cryptoeconomic Systems. What would you love to see? What should they keep in mind?
Shermin, would you like to go first?
I mean, just keep in mind to keep a diverse perspective of what you're trying to build. I think, I just want to underscore what Z said. Whatever system you're building, especially, I mean, if you want to tokenize securities, that's the complexity of that is not the technical and legal complexities are overseeable, right? But if you're trying to create a token system that steers a DAO, right? You need people from different disciplines, and depending also on the purpose of the DAO you're building, to be able to co-design the system with you from the different disciplines. Take enough time to cater to the needs of the different disciplines. Obviously, you can't be a scientist when you're building something, right? But the hardest thing, I guess, is to be pragmatic, between taking enough time to look at the different perspectives that are necessary when you're designing your token system, and keeping the things as simple as possible, but having complexities where they're necessary, and acknowledging complexities or where they actually exist, and acknowledging the fact that you can't foresee every potential complexity or a potential future outcome, but have procedures for unforeseen complexities that might arise in the future based on the system you're building.
Perfect. Z, what would you add?
And I'm going to sort of like riffing on that. I would say that always in engineering, you want the simplest representation, but no simpler. And I think it's important to remember that with the socio-technical systems, we're not actually building on a blank sheet of paper. There's some like underlying social dynamics. There's some phenomena that you want to, sort of create or empower. There's what a control theorist would call a plant, a system prior to your intervention. And so you don't do yourself any favors by neglecting the system as it exists in the absence of your intervention. Actually mapping and understanding the phenomena before you introduce your tokenized system or your any system, your mechanisms, your policies, etc. And with this in mind, I'd also like to sort of highlight the fact that this interdisciplinary approach, it really begs a team. It's like a thing where, sure, you read the paper, you get a sense of the big picture. Let's say it's breadth first. Like we're saying, like, look, there's a really wide horizontal of things that you should at least be aware of that are relevant to what you're doing. That doesn't mean go try to become the expert in every single one of them. Much like early data scientists, current token engineers are often being pigeonholed into this role where they're somehow supposed to be everything to everyone all at the same time. And in my opinion, this is a trap. It's the same trap that the early data scientists fell in. Oh, you're the like popular like new job title and you're awesome and you feel good about that until someone hands you a task that should be done by a 5-person team and then gets upset when it's not done in 2 weeks. And you're like, okay, that's a 5-person team in 6 months that's actually capable to do the task. And I don't mean like overcomplicate it. I mean that the number of different perspectives that you should be taking into account should be is significant enough that you wouldn't reasonably expect someone to be the, in the data science analogy, you might have the domain expert for the business that you're working at. You might have who has some SQL experience and can do some basic manipulations. You might have a data engineer who's really like familiar with the database systems and the storage and the transformations and all the ETLs. And then you might have an analyst whose job is to do visualizations and build understanding. And then you might have another person whose job is to be a machine learning engineer who's actually going to start taking those insights and build algorithms that's job is to mine the information that's available to facilitate some decision making. And you might even have another person who's more of like a product manager whose job is to say, yeah, we could predict that, but that doesn't actually make life better for our users. Our users want this other thing. And so suddenly you have this team of people all working together to try to define what is a good solution to build a thing that satisfies that and iterates, but they're all kind of grabbing a different perspective. And I think we're in a place right now where token engineering sometimes is like, well, oh, like we have a token engineer now, so it's going to be great. Like people used to do, oh, like we have a data scientist now, it's going to be great. When you're just lumping all of these different perspectives into this one catch-all term, and that's just dangerous. And I think as time goes on and the complexity is respected, we're going to end up with sure, breadth first. Everyone who's going to work on that team should have a sense of the other team members that they should be able to communicate with, collaborate with, but otherwise they can specialize. So in a token engineering context, you're going to have, mathematician mechanism designers who can take sort of formal requirements and say, this mechanism has these properties. You're going to have sort of data scientist types who can comb through the chain and say, hey, with mechanisms that are similar, here's the kind of behaviors that we've seen in the past. We're going to see simulation engineers, people who use token spice or CAD/CAD or something like it, and they create representations that prescribe what we would hope it would look like, and analyze scientifically the circumstances under which the policies being proposed would generate the desired properties, and then use that to inform some policy making. But you're also going to have some people who are more economically oriented, who might have experience with systems in the legacy world that have similar interrelations between, say, of behavioral economics and zooming out to something like monetary economics to talk about things like the difference between a monetary base increase and actual inflation. And so like all of these facets. And then next you're up to like, okay, policy making. And you're like, wait, these algorithms are actually just subjective rules that are decided upon and then put into practice with desired outcomes. There's a political science and sort of like community governance aspect that's bubbling up there. And okay, like who's going to do that? And are there checks and balances? And so as we sort of double click on each of those things, you realize that it's totally not fair. And in fact, arguably problematic to try to put all of that on the head of one person, but instead to build teams that are capable of allowing one person to say, look, I went out and I figured out, I'm product manager hat on. I went out and figured out what we think the users want, not how to accomplish that, but just like what we think they actually want. Another person's going to be like, cool, I derived a mathematical equation that we can put in the code that I believe will create that. But then there's going to be other people doing the economic and political sanity checks on those things. So like, no, I know that sounds great, but you assumed A, and we really shouldn't assume A, because look at these counterexamples, or look at what happens if we're wrong and it's A prime. And so that's a team. And that's the way I really want to like focus. Go ahead.
Thanks.
Yeah, I think it's just to maybe also to round this up, I can everything like this is Z made a very good point with his example. And to round it up, I think what's really important to understand for token engineers, especially when you design tokens that steer DAOs that have community governance mechanism, once you have the initial, and I quote Z here, who once said, as we were writing the paper, initial conditions matter. You know, it's really important to take time to discuss your assumptions, to take time, the different perspectives, to invest a lot of time into designing the initial economy and to test the initial economy, right? Because once you have the system flying, it's really hard to do system upgrades because you need consensus for that. And then you have different interest groups and you already have power structures in your system, right? So why should a miner in Bitcoin vote for less fees, for example, right? So once you have the power structures established in a democratic or like in a co-governed system, it's really hard to get them out again. So which is why initial conditions matter. Take enough time to design your system. It will never be perfect. Understand that it will never be perfect and account for the fact that it will never be perfect and how to deal with the imperfections, you know?
Awesome. Amazing. Thank you so much, Shermin and Z, for this introduction. And I'm sure students will be super happy digging into your paper and more.